Hi there, this is Mr. Khan from 11 Plus and GCSE Coach. This is part 2 to the video on sequences. If you haven't seen the first part, please watch that video first before carrying on with this. Now, what is the nth term rule? This deals with the nth term rule of a sequence. Here's an example. If I ask you to find the 500th term of a sequence, up until now you've learnt a rule that to get from one term to the next term, you find the difference and you carry the difference on to find the next term. Now, clearly, you can't find the 500th term by finding the 499 terms previously and then get to the 500th term. That won't be a very good use of your time. So there must be a better way. Now, that way is known as the nth term rule. Now, how it works is this. Each term has a position. So, for example, this is the first term of the sequence. This is my second term. This is my third, and so on. This is the fourth and fifth term. It carries on, but where does it stop? It stops wherever you want it to stop. So wherever it stops, you call that number n. So it becomes the nth term. Now, to find the rule, what you do is you find the difference as before. So from 3 to 5, the difference is plus 2. From 5 to 7, the difference is plus 2. From 7 to 9, the difference is plus 2. And from 9 to 11, the difference is also plus 2. As I said in the first video, please make sure you get the difference for all the terms given in the sequence, because sometimes the difference does change when you go further on in the sequence. Anyway, you find the common difference, which is plus 2. You simply times that by the letter n. N is the position, so 2 times n. So we're going to say this is our nth term rule, 2 times n. But we need to check to see if it's the correct rule. Remember, n represents the position. So you always take the first one because that's the easiest one. My first position is the number 3. So that's the first term in the sequence. I need to check that 2n produces the number 3. Remember, n represents the position. So all I do is replace n with the number 1, 1 for the first. So 2n becomes 2 times 1. Now 2 times 1 is obviously 2 and not 3, which is what I need. So that means if I add 1 to the 2, I get the number 3. So that adding 1 is the additional part to 2n. So 2n plus 1 will become my nth term rule. So I know this much now, that 2n plus 1 will produce the number 3. Now I need to check that will it produce any other number in the sequence to make sure if it's right. So let's take, for example, the third term in this sequence, the number 7. Let's check this rule to see if it produces the number 7 for the third term. So my nth term rule is 2n plus 1. Now n represents the position. I want the third position, so I'll replace n with 3. So 2 times 3 plus 1, do I get 7? Well, 2 times 3 is 6, add 1 is 7 indeed, so I do get 7. So the 2n plus 1 rule works for this sequence. Let's try one more time to make sure it works for all of them. Let's try the fifth number. So I've got 2n plus 1 as my nth term. I want the fifth number, so I'll replace n with 5. So 2 times 5 plus 1. Well, 2 5s are 10, plus 1 makes 11. So it does work. So that means 2n plus 1 does work for all the terms in the sequence. Now, what's the benefit of that? Now I can go ahead and find the 500th term if I want to. So I replace n with 500. So that becomes 2 times 500 plus 1. So 500 times 2 is 1,000, plus 1 is 1,001. Very easy. I don't have to find the 499 terms before that. Hopefully that made sense and you can see the benefit of finding the nth term of a sequence. So here are more examples. Let's find the nth term of these sequences. Well, from 7 to 10, the difference is plus 3. From 10 to 13, the difference is plus 3. 13 to 16 is also plus 3. And 16 to 19 is also plus 3. You find the difference and you times it by n, so it becomes 3n. You always replace n with 1 to test for the first term. So I do 3 times 1, which is actually 3. I need it to be 7. So 7, what's the difference from 7 to 3? So the way to find the difference is 7 take away 3 is 4. So I need to add 4 to that. So 3 plus 4 equals to 7. That means adding 4 is the additional part, so to the nth term. So 3n plus 4 becomes my nth term of this sequence. One more time, always double check to see if it's right. Let's take the fourth term just for the sake of checking. I'll replace n with 4 in this case, so 3n plus 4. I'll replace n with 4, so 3 times 4 plus 4 is 12, plus 4, which indeed is 16. So it does work. So 3n plus 4 is the nth term of this sequence. Hopefully you had a go at this question yourself before you check to see if it's right. Let's see. From 16 to 11, now you're subtracting. So 16 take away 5 gives me 11. 11 take away 5 gives me 6. 6 take away 5 gives me 1. 1 take away 5 gives me negative 4. So my common difference is minus 5. I simply times it by n, so it becomes minus 5n. So now I replace n with 1 always to see what the first term is. So minus 5 times 1 gives me negative 5. But my first term is 16. So what's the difference? Remember, you do 16, take away minus 5 to find the difference. So just to work it out on the side. 16 take away negative 5. So be careful when you have negatives. It will become positive 21. So that means I need to add 21 to this. So minus 5 plus 21 gives me 16. So that plus 21 is the additional part to minus 5n. So minus 5n plus 21 is the nth term of this sequence. It can be written as 21 minus 5n. It doesn't really matter as long as you put the negative for the 5 and not the 21. You can double check to see if this works. Let's try the fourth term again. So let's see if it gives me 1. So I do 21 minus 5n. Remember, n is the position on the fourth term. So 21 minus 5 times 4. 5 fours are 20. 21 minus 20 is 1 indeed. So it works. So this is the right rule for this sequence. Have a go at these questions. Pause the video and see if you get them right. Hopefully you had a go at these questions. So 4 to 7, add 3. 7 to 10, add 3. 10 to 13, add 3. So it becomes 3n. And then you replace n with 1. So 3 times 1 is 3. I need the first number to be 4. What's the difference? I do 4 take away 3, which is positive 1. So I need to add 1 to this to make the number 4. So the add 1 is the additional part of the nth term, which is 3n plus 1. And you can double check that. Let's say the second term, 3 times 2 will be 6 plus 1 is 7. And second term is 7 indeed, so it works. Hopefully you got that right. Next question, 6 to 10, add 4. 10 to 14, add 4. 14 to 18, add 4. And 18 to 22, add 4. So my nth term will be 4n plus something. What is that plus something? Well, if I replace n with 1, it becomes 4 times 1, which is 4. I need the first term to be 6. So what's the difference? Always do the term that you have in the sequence, which is 6, take away the one you just got, which is 4. 6 will take away 4 is positive 2. So I need to add 2 to this to make 6. That means add 2 is the additional part to 4n. So 4n plus 2 is my nth term for this sequence. Always double check. Let's say if I want the fifth term, 4 5s are 20, plus 2 is 22, so fifth term is 22, so it's the correct answer. Hopefully you got that right. Now this term here, you're subtracting 5, take away 5, take away 5, take away 5. So your nth term starts off with minus 5n. You replace n with 1, so minus 5 times 1 gives me negative 5, but I need the first term to be 25, so find the difference. So I do 25 take away, always take away whatever you got. I got it to be minus 5. So 25 take away negative 5. Remember, two negatives make a plus when then they're next to each other. So 25, 2 and 25 take away a minus 5. Taking away a minus same as adding. 25 plus 5 equals to 30. That means the additional part is add 30, which will give me 25 in this case. So add 30 is what I need to add to the nth term part. So minus 5n plus 30 is the total nth term of this sequence, which could be written as 30 minus 5n. So both of them are the same thing. And always double check. Let's say I want the second term again. I replace n with 2. So minus 5 times 2 is minus 10. 30 take away 10 is 20. So it does work. So that's the right answer. Hopefully you got these right. Generating sequences from the nth term rule. So remember, you can actually find any term you like from the nth term rule. I already mentioned that before. So if I wanted the 500th term, I would simply replace n with 500, as 2 times 500 would be 1,000, plus 1 would be 1,001. Same with if I want a 1,000th term, I can replace n times 1,000, which is 2,000, plus 1 would be 2,001. That's one benefit of it. The second benefit is you can check if a number is in the sequence. So let's say if I want to see if number 58 is in this sequence or not. Well, I got the nth term rule, which is 2n plus 1. I simply make it equal to 58. Now, I need to solve this to find what n is. If you haven't seen the video on algebra, please watch that first. So minus 1, take away from both sides, you end up with 2n equals to 57. And you divide both sides by 2, and that will give me half of 57. Now, n, half of 50 is 25, and half of 7 is 3.5, that'd be 28.5. Now remember, n is the position. Now there is no position which is 28.5th position. You have the 28th position or the 29th position, but you can't have a decimal of a position. That means n can't be decimal. That means this number cannot be in the sequence, because n, if it was, n would be a whole number, n would have been the position. So there's no position that gives you 58. This number is not in the sequence. And that's another benefit of the nth term rule. Okay, now these are the last few questions. Have a go at these questions and pause the video when you're ready. Play the video to see if you get them right. Okay, so hopefully you've had a go at these questions. I need to generate the sequence, first 5 terms. So replace n with 1. So 3 times 1 plus 2. That gives me 3 plus 2, which is 5. That's my first term. My second will be 3 times 2 plus 2. 6 plus 2 will be 8. That's my second term. 3 times 3 plus 2. That'd be 9 plus 2 is 11. 3 times 4 plus 2. That'd be 14. And 3 times 5 plus 2, which would be 17. So these are the first 5 terms of the sequence. Is this in the sequence number 84? I can check that. 3n plus 2 equals to 84. I take away 2 from both sides, I end up with 3n equals to 82. If I divide both sides by 3, I end up with n equals to 3 goes into 8 twice, remainder 2. 3 goes into 22 7 times with the remainder 1. Because there's a remainder, n is not a whole number. That means n is not a whole number, which is not a position then. That means 84 is not in this sequence. Hopefully you got that right. N has to be a whole number for it to be in the sequence. Okay, the next sequence, replace n with 1. So 2 times 1 plus 7, which will give me 9. 2 times 2 plus 7. Remember, you replace n with each position you want. 2 times 4 is 7, plus 4 is 11. 2 times 4 is 4. 2 is 4 plus 7 is 11. 2 times 3 is 6 plus 7 is 13. 2 times 4 is 8 plus 7 is 15. And 2 times 5 is 10 plus 7 is 17. Now, is this number in the sequence? I simply subtract 7 from both sides. So I end up with 2n plus 7 equals 126. Or minus 7 from both sides. I end up with 2n equals to 119. I divide both by 2. Because this is not an even number, it will not give me a whole number as an answer. So that means it's not in the sequence. This number is not in the sequence. Next one, replace n with 1. 5 times 1, take away 4. That gives me 5 take away 4 is 1. 5 times 2, take away 4. 10 take away 4 is 6. 5 times 3, take away 4 is 11. 5 times 4, take away 4 is 16. And 5 times 5, take away 4 is 25 equals 21. Is this in the sequence? Simply 5n minus 4 equals to 96. Add 4 to both sides. That gives me 5n equals to 100. I divide them by 5 both sides. That gives me n equals to 20. That means it is in the sequence because it's the 20th term. Okay, the next question, 7 times 1 take away 1 is 6. 7 times 2 take away 1, 14 take away 1 is 13. 7 times 3 take away 1 is 20. 7 times 4 take away 1 is 27. 7 times 5 take away 1 is 34. Okay, that's the first 5 terms. Is in 42 in the sequence. 7n minus 1 equals to 42. Add 1 to both sides. 7n equals to 43. N equals to, well, 7 does not go into 43. 7 6 is out of 42. So that means it can't be a whole number. That means this number is not in the sequence. 43 divided by 7 will not be a whole number. It will be 4, 6 remainder 1, which can't be in. N can't be a part number, a decimal number, so this number is not in the sequence. Finally, 4 take away 2 times 1. So 4 take away 2 is 2. 4 take away 2, 4 take away 2 times 2. So 4 take away 4 is 0. 4 take away 2 times 3. So it should be take away there. 4 take away 2 times 3. 2 times 3 is 6. 4 take away 6 is minus 2. 4 take away 2 times 4 2 times 4 is 8. 4 take away 8 is minus 4. And 4 take away 2 times 5. 4 take away 10 is negative 6. So these are the first 5 terms of the sequence. Is this number in the sequence? Let's check. 4 minus 2n equals to minus 20. I take away 4 from both sides, end up with minus 2n equals to minus 24. I divide both sides by minus 2, end up with n equals to minus 24 divided by minus 2 is positive 12. That means this number is in the sequence. It's the 12th term in the sequence. Yes, it is in the sequence. Hopefully you got these questions right and it made sense. Thank you for watching.